Hello, Flat Earth researchers, debaters and debunkers. This is a response video to 20 questions Flat Earthers can't answer by this guy John on the channel Respect Your Intellect. It's going to cover some old ground as far as seasoned Flat Earth researchers are concerned, so it's a bit tedious there. It's certainly tedious for me, but it's an opportunity to point out some of the differences, or this wide gap of misunderstanding between people like John, who are defending the globe Earth model, which he continually refers to as scientific explanation, and people who have examined the globe Earth model and realized that it doesn't really fit our reality. So we'll just go through it, and I'll stop him where I feel is necessary. I might have a few examples of my own to present. We'll see how it goes.
Usually we're the ones addressing the problems with Flat Earthers' fantasy world. Today we'll be
Okay, he calls our world a fantasy world. No, it's just grounded in the reality that we experience a non-moving plane, and that's about as much as we know. We don't know what's above or below or beyond. We don't know the full dimensions or limits or extents of this land that we find ourselves on. So there are no real imaginary theories and things about where we are in space, if at all. It's just a realization of the difference between what we know and can prove, which is very, very little compared to what we believe about where we are, which is a lot. Maybe I may as well address it now, but ultimately, whatever side of this argument you are on, we're talking about trying to find answers to the fundamental questions of creation, the creation of this Earth, how it came about, why it came about, and when it came about. Yeah, this is all to do with the creation of the Earth. So the heliocentric globe Earth model, which John here is defending, is a creation story. Big Bang, all the mass turned into balls of mass, and da 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 da, everything spinning around. Yeah, so this is a religion in itself. That's what you have to understand. It's a religious way of thinking. It's dogmatic because it's a belief in the Earth's place in space, in the universe, the creation of that Earth and how it came about. This is all about having faith in a particular theory on how it all began. So even if you have this Big Bang theory leading to a heliocentric model, you still do not have an answer as to the how and the why it all began. All we have is models that represent what we see going on in the sky. And if anyone with any real discernment can look at all the models and realize that they're all interpretations of what we see on the Earth, but anything that goes beyond that is the fantasy. Now, of course, it would appear that it's been scientifically proven that we've gone to the moon and we're sending rovers to Mars and what have you. This, of course, remains another part of the debate. But that's something people can research on their own and look into the possibility that all this footage from space that we are given is not actually done in space. Anyway, let's carry on listening. Got off sidetrack there, but these are all important aspects of what John is fundamentally talking about. Is his model, which he considers scientific fact, about how, when, why the Earth was created.
asking a series of questions that the globe model has had perfect answers to for hundreds of years, and we'll see if flat earthers can answer these questions as clearly, concisely, flawlessly, and elegantly as science can.
Okay, he says that science has perfect answers for all the things he's going to point out, I suppose, which I presume are mostly to do with observations. So, yeah, I'm sure we'll come across some examples of you being asked to come up with the science fact to back the claim. Let's see.
Here are the challenge rules. 1. No calling fake or lies, since you can experience all of these for yourself.
Okay, yes, we can all experience fakeness or lies. Okay, can happen to any one of us, including the intelligentsia.
2. No mention of religion. This is only about the shape of the earth.
Okay, so again, that goes back to the original point I made. This is about the shape of the earth, yes, but that is also a belief. It's a faith. So it's a religion. Okay, so again, we're just talking about a different creation story that you're sticking to, that you consider science. Okay, so it is about religion because it's about the shape of the earth.
3. Hearsay is not considered evidence. Quotes, newspapers, articles, books, etc.
Okay, hearsay is not considered as evidence. I will hold that same rule to you, John, when you present your evidence. Okay, so no, books, newspapers, articles, etc. You can't use basically third-party information. You're basically talking about having that knowledge yourself as being one of the rules to supporting or defending a model. So let's keep that in mind as we go through this.
4. All questions must be answered.
Whatever. You'll get an answer, but it doesn't mean that you'll get the answer you want.
Anything less is regression. And 5.
Anything less is regression. There is nothing wrong with taking a step back. In fact, that's what science does. If it goes down a particular path or avenue or way of thinking, a theory, and that theory doesn't work out completely, then you take a step back and then you know that you can now have a look in another direction. That doesn't mean you regress. Advancement or progress is made by taking side steps and back steps and reassessing your position, and that's what science is supposed to be. So there is no regression here. If we keep on blindly blundering forwards without really knowing the truth, then that is regression. Number 5, he's going to say answers must be more complete than what the globe model offers. Okay, I'm not sure how complete those answers are, but again, you're talking about a model. We're talking about the difference between models and reality. Okay, John, there are many, many models. Any rational person can see that you can create a variety of models from the things we see in the sky, whether it's a lunar calendar, a solar calendar, yes, because all we're doing is measuring the passage of time. That's what these models are when we see things appear, just like the hands on a clock, okay? So, you know, the planets and what have you, they all become cogs in the watch. And so really what we're talking about is a timepiece and keeping time, watching time, tracking time. So any model can be derived from these observations. So to assume that you have the right one and know the mechanics of it is presumptuous, to say the least. So I doubt if you actually have any complete answers for the model. Maybe in of the model itself, if you look at the model on paper and you say, okay, this is here and this number here and that, maybe you have these complete answers in a mathematical model, but that doesn't mean that they actually fit with our reality. Let's see where this takes us.
5. The answers must be more complete than what the globe model offers because, again, anything less is also regression. Those are the same standards given to anybody else with a...
It's really quite silly to call the... That's twice now he said that thinking anything differently is regression. Progress is only made by adapting and changing one's thoughts sometimes.
Claim throughout history, so you're not being held to a higher standard by any means.
Okay, so let's remember that we'll hold John to the same standards that he's invoking here. Keep number 3 in mind. I think it will be pertinent.
Also keep in mind that the flat Earth model does not only make claims about the shape of the Earth. The Earth being flat is the foundation for the claim, but it also claims that the Sun and Moon are only 3,000 to 5,000 miles away.
Okay, this is obviously the information given out by the Flat Earth Society, which I suspect is where John has got most of his information. But for the most part, there isn't really any solid agreement on the distance to the Sun and the Moon, although there may appear to be in the heliocentric model. Again, these are numbers that were changed over time based on various things, just to realize when maybe someone realized that a number didn't fit for one of the equations, then some changes were made. That's the kind of adaptation that has gone on in the history of the globe Earth model. If you just attempt to reverse engineer the globe, you can see how it was pieced together, and the things that had to be put in as mathematical quirks rather than something that is an observational reality.
That the stars are just lights on the dome, that gravity doesn't exist, and that Antarctica is not a continent but rather an impenetrable wall of ice.
Okay, again, he's referring to what some might call the standard flat Earth model, which is not necessarily advocated by all, just it's one that has cropped up as an image. So I'm personally not advocating an ice wall because I don't know if one exists. Kind of makes sense for a model of limited proportions, but that's not necessarily what we're confining ourselves to. The whole point here is to see if there is in fact more land beyond what we are told there is, and there are very few of us that can actually go and verify this for ourselves. Anyway.
Guarded by military. The flat Earth argument extends well beyond just the shape of the Earth. It extends to all things we can observe from the Earth that don't make sense on a plane. Then it also extends...
Okay, I'm not sure what he means by things we can observe from the Earth that don't make sense on a plane. I assume he's going to reference sunsets and things like that, which he may not be able to perceive as being possible. Let's see.
Tends to the forces we experience, like gravity, that can't be explained on a flat Earth.
Yes, gravity is just weight, and as long as something is denser than the medium it's in, it will sink. If it's less dense, it will float. Gravity is weight. That's all it is. There's no other external force required.
So don't start dismissing questions because they're not about the shape of the Earth. The implications of your model extend to a multitude of other objects and forces that you...
Okay, the implications of your model extend to a whole whatever. And the same goes for the globe Earth belief. We have to believe that we can do the physically impossible, which is to stick around the outside of a ball. This is a fantastical idea that we cannot base in any of our real life experiences. No matter how much we try to measure it scientifically, this is not something that's ever been proven. So, kind of losing my train of thought there. Let's let John carry on.
You have to be able to explain better than what we already know. Okay, enough of the...
Okay, have to be able to explain better than what we already know. He's assuming that we know everything, and the model has been given to us as knowledge. and so we have to come up with something better. We're not allowed to say that actually nobody knows, so let's start fresh. We're not allowed to admit that, are we? That's kind of part of the problem. There's this idea that it's all been buttoned up, and of course you've got, we'll come to it later I expect, the whole idea about what's powering all of this, which will be an interesting thing to just touch on, but let's go through the questions.
Introduction, let's start. Question 20. Why has the ice wall never been seen? Even if you subscribe to the ridiculous idea that it's being patrolled by military from all countries working together, as if they can get along well enough for that, then surely a simple telescope on a clear day would be enough to see it without actually needing to go there yourself. On the flat Earth map, the southernmost parts of South America, South Africa, and Australia should be the closest and least obstructed. Scientific answer? The ice wall doesn't exist. Antarctica is a continent like the others, at the south pole of the planet. It just has more ice because it's cold there.
Okay. As I said earlier on, I'm not necessarily an advocate of an ice wall, but the ridiculous question, part of that question was, why can't I see it with a telescope? I can't remember if he said from where, but I mean, that's just silly to ask such a question. You just can't see very far in any conditions, regardless of the shape of the Earth. So even if you assume it's flat, you're not going to see any further than what we can on any given day due to the density of the air, haziness, or whatever, just light conditions, what have you. So how many people can actually confirm any of this for themselves anyway, whether Antarctica exists as a continent or an ice ring? There are not many of us that are actually going to get off our asses and go and find out. Hopefully people will find out for themselves one day, but this is the start of thinking about what we can actually prove for ourselves. So already he's relying on third-hand information to debunk his claims that are also based on third-hand information. So that's all. I mean, it's hearsay on both sides. He's using hearsay to debunk hearsay. So question 20.
What's the flat Earth explanation?
Yeah.
Question 19. Why do boats disappear bottom first? Flat Earthers like to use videos or pictures of boats that are near the horizon but never past it. I imagine that's because they can't explain it without using terms they don't really understand, like refraction and atmospheric.
Okay, that's, again, unnecessary and uneducated and ignorant to say that terms like refraction are not understood by flat earthers. You know, I really shouldn't be giving this guy the time of day, but I'm doing it in the hopes that some people can see the vast difference between someone who hasn't even thought about the model they're defending, hasn't even researched the topic that he's attacking or the people in that topic, and then, you know, the difference between someone like that and people who have already been questioning these things for a long time. Okay, let's hear the end of the question.
Lensing, which don't really help with their explanations anyway. But take a look at these. Oh, and if you want to see the...
He said, so refraction and lensing don't help with the explanations anyway. So that's not considered a part of the argument at all, nothing to do with what we see due to conditions. Okay, so that's ignorance, John, to ignore the conditions that surround an observation.
The full videos that are referenced here, all the links will be in the description. In this one, the ship is not very big, so we'll be able to see it go past the horizon, then reach the vanishing.
Alright, just, this is a very old video, and one that's, it's been recycled so many times, but take a look at what the detail we see across the surface here, looking at this boat. The shot's already zoomed in to an extent, okay, but the boat isn't that far away.
Vanishing point before being completely below the horizon. Here we have the boat just about on the horizon. Here we have the boat past the horizon.
Okay, so it's gone further away, and it's now kind of part of the band of convergence, which is partly mirroring and obscuring everything, and we have a very low shot so the across this water here, and again it is zoomed in, but we'll see a bigger difference in the next shot.
And here we have the boat reaching the vanishing.
Right, so here we can see a lot more detail in the water and a lot more movement. If we just go back and look at this one.
Reference here, all the links will be in the description.
Sorry.
In this one, the ship is...
Yeah, okay, here's this kind of the water here. Compared to the water here. Okay, so you can tell that we're zoomed in a lot more. And actually a bird comes
reaching
down.
the vanishing point before being completely below.
Right, so this bird coming down shows you how far zoomed in this person is. It also shows that there isn't that much distance to the horizon between the bird and what appears to be the horizon. This is just an optical phenomenon that occurs on the surface, especially when we're low to the surface, and it will cut off more distant objects, because here is what is called the apparent horizon, the line on the surface, but in fact the surface extends beyond that, but the angle of incidence at which the light is returning to our eyes from this flat surface in the distance is too shallow. So this is where everything becomes mirrored and converges in the band of convergence just above the horizon line.
The horizon, because it's a pretty small boat. Now in this one, we're looking at the Golden Princess, which is a huge cruise ship. The guy films a completely uncut version of 1 hour showing the Golden Princess going below the horizon, and it's big enough that it doesn't reach the vanishing point before being completely below the horizon. Keep in mind that this ship has a height of 177 feet, so around 150 feet above the waterline, which is almost as high as the Niagara Falls, so it's very, very tall. As if it wasn't enough that he filmed this.
Okay, it doesn't matter how large the vessel is. The further away it gets, the smaller it will appear to be. And we can see this is a very low shot here, and it's zoomed in with these waves appearing to crash right in front of the camera. So we can see that this is very low to the surface. So it won't be long before waves of equal size or greater that are out there in the distance that we can't quite make out will eventually obscure the bottom of that ship, and you can see that it's already kind of starting to fade out anyway.
So clearly, once the ship is about half below the horizon, he also goes up a hill further back that gives him about 40 feet more elevation compared to where he was on the beach. As he does that, he shows that the cruise ship is now almost...
Okay, so this is normal across, he's looked across a level yet rugged or turgid surface from a very low perspective, and as usual the horizon has come up rather abruptly in front of the photographer, and gaining height allows us to see further. We see over those albeit small waves that block things. We have a better, clearer view, and what we'll find is that we are not looking down to this ship or to the horizon. We are still looking straight ahead. So that is the difference. That's what happens across a flat surface. Just keeping in mind that any surface outdoors is going to be like this. Water has got waves, it's got movement, there's temperature differences and fluctuations, and equally across land there are all kinds of undulations and textures. There's nothing ever entirely smooth. So that's a comparison that a lot of people make in this model, is that we should have this smooth um, surfaces to try and carry out these experiments. But you just have to look at reality and look at all the variables that are encountered in the observation.
Fully visible again, even if he moved away from it. And that's what we expect to see from a spherical Earth. Huh? See his video for the full uncut version.
He says that's what we expect to see with a spherical Earth. As explained, you expect to have to look down. If something's gone beyond a curve and then you go higher up to see that thing again, you in fact are having to look down more. So this is not something that's ever been properly measured as being done once we gain height. It's just an assumption that we're looking down a curve when that's never been measured in any way.
Scientific answer: ships always follow the curvature of the Earth and end up below the horizon. Depending on the ship's size and the zoom on your lens, it might reach the vanishing point before being completely below the horizon. But if the ship is big enough, like the cruise ship, you'll see it go below the horizon well before it reaches the vanishing point.
No, not necessarily. It really depends. On conditions, a ship might just disappear into the veil of the vanishing line before it ever has a chance to go apparently below a horizon. Ships or boats only appear to go below the horizon when you are low to the surface, gain some significant height above those waves and the rest of the surface, and you won't see the boat go down below the horizon. Ships can stay on the horizon and go off into the distance because that's what they're doing across a flat surface. So these are all arguments that are assumptions so far. Why do boats disappear bottom first? Well, they don't always disappear bottom first, but at the very least, a significant amount of the underside of a ship is going to get cut off as it goes off into the distance, because the further away it gets, the smaller it appears to be. So that means that even small obstructions, such as waves, between the observer and the ship actually become large obstructions. They block off the entire ship at some times. And of course we have all the other atmospheric effects which you didn't want to take into consideration: refraction, mirages, and the differences in heat. The fact that dense air is going to be closer to the surface means that even if we look across a seascape when we don't see any ships, then we will see this sudden, what appears to be an edge, really, with this horizon line, and that is also at this point in the distance where air is denser, so the light is bending down. This is a scientific explanation for what you conclude as being on a ball when you haven't observed that many ships, it seems, or looked at many videos of ships disappearing, just made interpretations that are related to the globe Earth model. And that's all the globe Earth model is. It's just interpretations of the observations. We're told to see the sun rise and set and interpret that as being because we're on a spinning ball Earth, with no other scientific fact or measurement to back it up, just a model that's drawn on pieces of paper with numbers attached to it.
What's the flat Earth explanation? Question 18. How are lunar eclipses possible and always circular? This one is a pretty simple question. How are lunar eclipses possible if both the sun and the moon are the only two things orbiting above us? In your flat Earth model, there are also claims that the moon is its own light source. If that were the case, how could a shadow even be cast on it? Scientific answer: the Earth is a sphere that sometimes passes between the sun and the moon to cast a shadow on the moon.
Okay, so this breaks rule number 3, John. This is hearsay. It's some kind of image from somewhere that hasn't been observed by anyone. So it's not from your own knowledge. And also it has this representation of the sun and the earth and the moon being in direct alignment, whereas it appears that most lunar eclipses occur when both the moon and the sun are above the horizon. So whatever is creating the shadow on the moon is quite possibly another celestial object that we don't know anything about. Who knows? But it doesn't necessarily mean that it is a shadow from a globular Earth like this. So anyway, your evidence here is hearsay, so it doesn't really count, does it, as an argument?
Spheres are the only shape to always cast a circular shadow. Also, the moon is not
A dinner plate will cast a circular shadow.
a light source. It just has a reflective curved surface that sends some of the light it receives back down to us. What's the flat Earth explanation?
Okay, the moon. Who knows what it really is? It's a part of the cosmic clock up there. It tells us the time, and who knows whether it's reflecting sunlight or doing a bit of both, producing its own light, or light from a different source, or it's translucent. It's very difficult to say. But the sun and the moon behave in precisely the same way as far as their paths and apparent distances and sizes from the Earth. So you have to produce some proof that that's what they're doing. You're talking about the reflective properties of the moon. We don't see the kind of reflection we would normally see from a spherical object, although we do see shadows and light that can be recreated or modeled with a concave moon. So that's worth looking into. Might sound ridiculous, but it's a scientific explanation, because if you take something concave and you shine the light on it, you can get the same effects that you do with the moon. So I'm not saying that's solid proof, it's just another explanation which works.
Question 17. How is Earth's magnetic field generated? Earth's magnetic field is what prevents our atmosphere from being stripped away by the charged particles we receive from the sun. Without it...
Ooh. Okay, so he's claiming that it's the magnetic field that stops the atmosphere from escaping from the globe Earth. Not gravity, or maybe it's a combination of the two, I'm not sure, but let's keep that claim in mind, that it's the Earth's magnetic field which apparently holds the atmosphere in now, stops it getting ripped away by, hang on, what did he say? It's just...
it receives back down to us. What's the flat Earth explanation? Question 17. How is Earth's magnetic field generated? Earth's magnetic field is what prevents our atmosphere from being stripped away by the charged particles we receive from the sun.
Okay, prevents the atmosphere being stripped away by the charged particles received from the sun. So you're saying that the charged particles from the sun are strong enough to rip off the atmosphere if it wasn't held down by a magnetic field. Okay, let's just carry on.
Without it, the solar winds would strip away our ozone layer, which protects us from the sun's harmful ultraviolet radiation. Scientific...
Okay, there's another presupposition there that ultraviolet light is bad for you, that the ozone layer protects us from this dangerous sunlight. Also, there's a whole bunch of beliefs bundled into this little statement here, but...
Scientific answer: Earth's core is composed of very hot iron that can't turn liquid due to the extreme force of gravity there. However, the outer core is liquid iron. As the iron warms and cools, it rises and sinks, causing convection currents. The Earth's spin also contributes to the swirling of matter in the outer core. The motion of these convection currents of molten iron generates electric currents. These electric currents are the source for our magnetic field. Science hasn't confirmed this with absolute certainty yet, but our current evidence is pointing strongly in that direction. So although our degree of certainty is not perfect yet, it's still pretty good. What's the flat Earth explanation?
Okay, so you admit that this isn't an explanation that has been backed with any real science or discovery. It's an assumption or a theory at best. It assumes that we have this molten spinning core, where, as far as I recollect, molten. No, you said a solid iron core because of the pressure of gravity, surrounded by molten, whatever metal. But either way, molten metal loses its magnetic properties. Why does something have to be moving to create this magnetic field? I mean, magnets are just magnets. They don't necessarily move. So you're talking about a generator within the Earth, and then you're talking about all this liquid molten iron and metal sloshing around underneath the Earth because of the Earth's spin. Yet the oceans don't slosh around because of the Earth's spin. So again, you have all this idea that there's things spinning inside and we're spinning, it's all whizzing around, and everything's getting sloshed about to create this magnetic field with not an iota of evidence, really.
Question 16. What keeps the sun and the moon from simply falling to Earth? If the sun and moon are just hovering above the clouds a few thousand miles, what's the force that keeps them afloat there? Scientific answer? The sun and moon are not just above us. The moon orbits the Earth at 384,000.
Okay, just to point out, this is hearsay, so no one's actually measured the distance to the sun and the alleged Earth. No one's ever measured the spin, and I'm sure he's going to talk about tilt, which is just a mathematical anomaly to have to include in the model. It's nothing that you can actually measure or truly represent. Even high school textbooks will admit that. We have the idea that the moon is orbiting the Earth every 28 days. That's not necessarily true, because we see the Earth go over our heads every day, apart from the couple of days it's hidden when it's the new moon. But basically we see the sun and the moon go overhead, follow the same paths throughout the month, so it doesn't mean that the moon is rotating the Earth in any sense. It's just illustrated this way as an idea for a model that puts the Earth as another planet going around the sun. And when you decide to put the sun at the center, then of course, how are you going to have night and day? Even on a flat Earth, if it was orbiting like this, you wouldn't have night and day. So hence the need to make it a spinning sphere, and then you can magically get night and day by spinning this sphere and having it going around the sun to create the seasons. This is all just hearsay. It's just a particular model that's based on looking up at the sky. No one's ever taken a picture of this. You can't see this or measure it in any way, shape or form, apart from telling the time, knowing that the sun takes about 365 days to do its annual cycle, and the moon also has an annual cycle as well that also adds up to about the same amount, 365 days. So whether you put the sun or the moon at the center of your calendar, which is all this really is, you still get annual cycles, you still get monthly cycles, and you can do this down to the day and the hour and what have you. So what we have really here is a way of telling the time, or an illustration of the passage of time as seen from Earth as we look up into the sky. So this is hearsay, and it's not scientific proof. It's just a mathematical model with some numbers stuffed in here to solidify the model.
1,400 kilometers, and we both orbit the sun at 149.6 million kilometers from it. What's the flat Earth explanation? Question 15. What powers the light emanating from the sun, the moon, and the stars? In order for things to emit light, there needs to be a reaction that excites the atoms. As the electrons of an atom jump to a higher orbit, the atom holds more energy. When it loses this energy by having the electron jump back to a lower orbit, the atom emits a photon, which is the fundamental particle of light. This process is known as the emission of light. So where does the luminosity from the sun, moon, and stars come from in your flat Earth model, and how is it self-sustaining? Scientific answer: the sun's luminosity is caused by nuclear fusion, where atoms are smashed together under the tremendous pressure of gravity. This fusion creates energy that makes its way back up to the surface and is emitted as light and heat consistently. For the moon, it looks bright because it's reflective, and as it receives rays from the sun, it bounces some of them back toward us. The sun rays that hit the moon are all nearly parallel too, because the distance is so huge. So it also explains why we don't just have one glare of reflection as if you had shined a flashlight on a bowling ball from up close. As far as stars go, their luminosity is caused by the same process as our sun in general, because our sun is just another star. Some stars, like neutron stars, also emit light due to nuclear decay instead of nuclear fusion. Also, the temperature of the star determines the color of light they emit. Cooler stars emit red light, slightly warmer stars emit orange light, even warmer stars emit yellow to white light like our sun, and the hottest stars emit blue light. What's the flat Earth explanation?
Okay, there doesn't have to be an alternative flat Earth explanation. But what needs to be pointed out is the explanations and the assumptions that you've made based on the limited understanding we have of physics at the moment. There's the assumption that there's nuclear fusion going on in the sun, just because that's about as far as our own technology can go. And there's an assumption that the sun is just another star, when it's obviously something very, very unique. There's only one sun for us, so we cannot really compare it to anything else on the Earth or in the sky. And there's an assumption that this same process of fusion is and gravity. So gravity's compressing everything and creating the heat, and you get the explosions. So it's all being pressed in. So this is interesting because I'm talking about really the driving force behind the entire model. Come to that in a second, I think. But he talked about the colors of stars being representative of their temperature. That's in no way conclusive whatsoever. You look at a star, and we've got good cameras to do that with these days, and you'll see that you get a multitude of colors in a very short space of time when looking at the star, because it's flickering. They look like things that are above water. So there don't seem to be any more clearer pictures than that. There are a few, but it doesn't tell us anything more about what stars really are. And it doesn't tell us whether they're hot or cold, or how that light is generated in any way that you can say is scientific. All you can do is compare it to our limited physics here on the Earth and try to say that's how it all works up there. So again, there is this attempt to connect what's going on up there with the physics of down here, and say that it all works in the same way, and thus have your whole universe driven by gravity, the force of gravity. So hopefully that's not, so there isn't a flat Earth answer for what the stars are, because there isn't an answer for what the stars are in the first place. We don't know. We don't even know how the sun really works. We don't know where it is. We don't know, so again, you're making all these assumptions that you have the answers already, and that's the problem. You have answers for a model, but you do not have answers that are actually scientific, demonstrable proof. So let's carry on.
Question 14. If Earth is accelerating instead of gravity, where's the energy coming from? We don't feel speed, we feel acceleration. And acceleration requires a force to act on the object. Think about when you're driving on the highway and your back is not constantly being pushed against your seat. Other than bumps in the road and visual cues, it's as if you're motionless if your speed is constant. If it was true that the Earth was always accelerating upwards to keep us on the ground, this energy for a constant acceleration must come from somewhere, and the sun and moon and other stars would all have to follow the same rules to avoid colliding with us.
Okay, so that's again obviously this theory about the flat Earth that has been bandied about by the Flat Earth Society that he's picked up on. So that's a wrong assumption to make, that there is anything creating this force of gravity. Of course, this whole idea of a force of gravity is the driving force behind the heliocentric globe Earth model. So you assume that it has to exist in well, just all over the place, because it is the driving force behind the model. So you assume that that has to apply to the Earth. And of course, if gravity is based on mass, then you're assuming that the Earth has a specific mass, and that's what's creating this pulling force. And you mentioned an external force pushing a car, and then you get pushed back into your seat. So yes, what he's referring to is the physics there of acceleration and then linear momentum, but you have this acceleration created by an external force which pushes the car and then pushes you. So you're the extra weight you gain, or the extra gravity that you gain, is caused by an external force. So this scenario is what's being applied to the globe Earth model. The notion that you have to have an external force to feel the acceleration which causes the weight or the extra gravity that you feel on a linear scale. Yeah, so there's a whole bunch of stuff that's tried to be plugged into this globe Earth model and passed off as science, but when you use your discernment to detach them and realize how these pieces of real physics have been used to sticky glue the globe Earth model together with real physics and pass it off as a scientific explanation. Yeah, so that's why he talks about momentum in various ways, the acceleration being an external force. So there's this idea that's stuck in the heads that acceleration, basically dropping something down towards the ground, is influenced by an external force other than the weight of the object itself being dropped through the air. What I might do right now is bring up this. I'm not sure if you can see it there. Maybe if I bring it to about there. Okay, so this is a kind of very basic idea of the heliocentric model, the machine powered by mass creating the force of gravity. So gravity becomes the driving force, the god of this solar system, this universe. So what we have here is something that is, okay, we can see that it's a large mass, and so we give it 100 units of mass, yeah? And then this one over here is smaller, so we give it 25 units of mass. This is our mathematical model, and then we have this arbitrary distance between them. So all we have to do is just apply numbers and units of the measurement we are calling whatever the measurement we're using. In this case it would be newtons or what have you, and applying it to the circle. Now you could interchange these, and you could make this large circle 25 units, and you could make this small circle 100 units, just by saying that, oh well, this one has more mass. So an observation might be made of bodies going around each other in the solar system, and then a certain number of units of mass are applied to that body and a certain number applied to that body, and then you can say that, well, based on the inverse square law that gravity follows, obviously outwards from the center, which is going to be smooth because of this circle. It all is very helpful in this sense. You can use the inverse square law and apply it as a mathematical idea, and so that you create this distance between the two, because the gravity is pulling and pushing them both, but this one is less gravity because it's less mass, blah, 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 blah. It's just, they're saying that mass, the mass of something, creates the force. you're going to need two of them. Yeah? So I think that might raise that point later on, that you always need two masses to allegedly measure gravity. You can't measure gravity as a force emanating from the Earth in of itself. So really what gravity is just a conversion of weight. That's all it is. It's just that, okay, this has a particular weight in the medium of air, and the only way it can go is down. It doesn't dictate the shape of the Earth. It's just what it will do, because it started off on the ground and you lift it up and it's ready to drop. And if it was lighter than the air, then it would rise. It is this. Okay, sorry, I'm going to go back to, because he talked about. So of course he's going on about linear conservation of momentum. So if you're in a car and you get accelerated, then that external force pushes you back into your seat for a while, and then the momentum of your body catches up with the momentum of the car. So then you have linear momentum, which he started talking about. And so yes, from then on you're going to have a smooth ride. So if there are no other visual clues or little things that are going to be bumpy along the road, but as long as you have this smooth linear momentum, that's the same as not moving. So already you have this juxtaposition of assuming that you're moving at the same speed as something that's already moving, or the idea that it's not moving and you're not moving with it. You can choose either one. But the whole difference with the spinning globe is that isn't linear conservation of momentum. That's constant acceleration. So if you're spinning a sphere, then the direction that you're going is constantly changing. So a change in direction means a change in the acceleration. Yeah? So comparing that to the globe is nonsensical, because they're two different results of momentum. So you've gone way off there, really. And so where's the energy coming from? So again, I've just kind of this is the kind of crux of the model, I suppose, is that the mass, the presence of mass creates gravity, and then gravity is the driving force for all of it. So everything's spinning, but again, you have to have this creation story as to how it got spinning, a big bang out of nothing. Well, either way, you're trying to create a finite point, a point of creation, rather than just modeling what we see going on in the sky and calling it a mathematical model, trying to pass it off as scientific fact, to replace any other ideas of creation, because it still comes back to the same question: how did it all get going in the first place if it's moving and spinning? What is spinning? What is the Earth? These are the questions that we're trying to answer with science and any other. They're just the fundamental questions. They're not owned by any particular branch of science or philosophy. These are just fundamental questions that any human being would want to ask him or herself. And if we're told by the authorities that it's this way, and then you grow up and you think about what you've been told, and you consider how these people knew or didn't know or believed what they were told to teach us, then you can start thinking for yourself. But so far, John here is just taking the side of authority, using hearsay to defend his argument of what he calls a scientific model, which is just a bunch of numbers on paper and an assumption that mass creates energy.
Scientific answer: the Earth keeps us on the ground due to the gravity it generates. At any point in time, the entire Earth's mass is trying to pull us down to its center. It's just that the ground gets in the way. What's the flat Earth explanation?
Okay, I've just given you the explanation, but of course what you as a defender of the globe have to do is prove that this is in fact our physical reality. It's well understood that if your model is a sphere or a circle, then wherever you are on that sphere, then down is towards the center of that sphere. That's what down is on a shape or a form like this with no edges except one. That's the model, but is that our reality? No. You're probably going to talk about it, about with the stars and what have you, the way we can see the stars, and you'll say that that dictates the up and down for the people on the Earth. But there's no other scientific, demonstrable, measurable way to prove this idea. So again, this is hearsay, because it's some kind of image produced from who knows where, and it's not backed with any scientific proof. So there you go.
To pull us down to its center. It's just that the ground gets in the way. What's the flat Earth explanation? Question.
So just to finalize that, really, the explanation is that there is no assumption that the way things work on the Earth is the way things work up in the sky. Yeah? Again, this is the problem, this is the connection that the heliocentric model attempts to make, is it attempts to connect us to the heavens and give us the answers to life, the universe and everything. And of course it gives those people with that kind of knowledge a godlike status. And of course they're revering gravity as the god of the all-seeing, omnipotent god that rules the universe, space, time, contorted by gravity. So the flat Earth explanation is that dense things fall through less dense mediums, and less dense masses rise through denser mediums. That's it. That's as far as we can, and that's even, that's as far as you can say it is for any model or assumptions about where we are. It's just the way it is.